So this is number 4. You were assigned number 3 for your board problems. And the idea of doing these is that we're using identities and not triangles to figure these out. So I already know 2 things. I don't know what sine is though, so I've got sine of x I've got to find. I know that cosine is negative root 3 over 2. I know that tangent is root 3 over 3. I don't know cosecant. I don't know secant. And I don't know cotangent. Okay, 2 of these I can fill in real easy because we just flip over cosine and that will give us secant. So I flip cosine over, I get 2 over the square root of 3, but then I've got to rationalize that, so that's negative 2 root 3 over 3. Cotangent, I just flip tangent over, so I get 3 over root 3. I rationalize that, and I get 3 root 3 over, and on bottom I get 3, so then the 3's cancel, so I get the square root of 3.
Wow, perfect. That's crazy.
All right, now I still need to find sine. We have cosine is the negative root 3 over 2, and if I want to find sine, then I can use that Pythagorean identity, where sine squared plus cosine squared equals 1. And so I know that cosine is negative root 3 over 2, and I can square that. So then we get sine squared plus 3 over 4 equals 1. Subtract 3/4, so now I have sine squared equals 1/4. Square root both sides, and I get sine equals 1/2. But I have to figure out if it's positive or negative. So if we look at what we were originally given, tangent's positive, cosine's negative. The only place that happens is in the 3rd quadrant. And so sine then is the y value, which is negative. So this would be a negative 1/2. And then I can flip that over to give me cosecant, so I get negative 2. So your board problem number 3 should be very similar to that. Number 11, also very similar to that. You're using trig identities, but in this one, they only tell you that tangent is something and sine is negative, so then you can figure out what quadrant you're in. You just have more trig identities you use to figure them out. I actually want to get going on to the next section of problems. You guys were assigned 15 through 20. You were not assigned that next section, so I think I'd like to work on that next section just to kind of give you an idea of what you're supposed to be doing. Does that work? Okay. So I'm going to do 21 through 26. So number 21, I'm supposed to simplify, and it says that sine of x times secant x. And so I'm supposed to do whatever I can and try and match it up with a through f at the top. Okay, so far it doesn't match yet, but if you remember back to the last time we did identities, I would say things like change things into sine and cosine and see what happens. So for example, I know that secant, I can rewrite that as 1 over cosine. Right? So I'm replacing secant with 1 over cosine.
Why would I do that?
Well, because now I have sine over 1. So I have sine times 1, that's sine. I have 1 times cosine, that's cosine. And if you remember your quotient identity, sine over cosine is tangent, which is B in that set of problems.
So you make it look easy.
I know.
Wait, where'd you get B?
I'm looking at the book, and B is tangent. I'm trying to match these up with the A through F that they give us. So they gave us answers to try and get. We don't know which answer we're supposed to get, though, so we're matching it up once we get it.
No way.
Okay, 22, it says cosine squared times secant squared x minus 1. Now, as soon as you start seeing squareds, you should look at the Pythagorean identities and see what you've got. Okay? Now, there's an identity that says 1 plus tangent squared equals secant squared. So when you do this, I expect to see this worked off to the side. Now, if you look, this is very similar. It has some similarities, things in common with the original. So I've got this identity, I've got a secant squared, and there's a 1. And up here I've got secant squared minus 1. So what I'm going to do is I'm going to rearrange this so that it looks like this. So I'm going to take the 1 and move it over. So now I have tangent squared equals secant squared minus 1, which means secant squared minus 1 is the same thing as tangent. So I can take tangent and put it right here. So now we have cosine squared times tangent squared.
You just need to do that.
Yep,
It's just in your head.
just practice and seeing a bunch of problems,
Oh, wow.
which is why I'm going to make you practice a bunch of problems. Okay, not done because this doesn't match anything.
Oh,
Okay, so now I got to try and figure out what else can I do, and this is another place where let's just change things into sine and cosine. So I've got cosine squared times tangent is sine squared over cosine squared. Since I have a fraction, I'll make my other one a fraction. Cosine squareds cancel, and we just get sine squared, which is C. All right, next problem. Right? Yeah. All right. Secant to the 4th x minus tangent to the 4th x. That's a mess, huh?
Yeah, a little
Why
bit.
are you teaching high school?
Could you
You should be in college right now,
No.
teaching college.
I'm good.
The masters are, they make
Alright.
bank, don't they?
I feel like this is helping.
Okay, this one is probably, I think, probably the worst one of the whole thing. Yep, you're going to box it. So we've got secant to the 4th here and minus tangent to the 4th here. This is secant squared. This is tangent squared. One has to be positive and one minus, though. That way you get a negative tangent to the 4th. And when we multiply these out, this would be secant squared, tangent squared. This would be a negative secant squared, tangent squared, and these guys would cancel out.
Okay.
So now this becomes, I'm going to work at the bottom. So this becomes
Looks like a lot more work.
secant squared x plus tangent squared x times secant squared x minus tangent squared x. And yeah, it looks more difficult, right? It doesn't look any better. But I'm going to go back to that Pythagorean identity, 1 plus tangent squared equals secant squared. And I'm going to move the tangent squared over.
It's 1.
So now I get 1 equals secant squared x minus tangent squared x, which means secant squared x minus tangent squared x is 1. So 1 can be plugged in for this whole thing.
Oh my gosh.
So then I now have secant squared x plus tangent squared x times 1. And yeah, that's F. No, we can't plug it in for both of them because this is a minus and this one's a plus. So that identity up there, this identity set a minus, so we could only plug it in for the minus. But this happened to be the answer that they wanted. I was worried we'd have to do more plugging in because we could plug in for them a little bit more, but. Okay, next one. All right, so we have cotangent x times secant x. What do you guys think?
Well, I think.
Flip what the mods taught.
Flip them?
No, just do whatever.
Do the 1 plus cotangent squared, anything?
But there's not any squareds here.
Break down.
Like, I'm not gonna do the Pythagorean ones because,
Cotangent, 1 over tangent.
how about,
No, make cotangent the cosine over sine.
yeah, how about we change everything into sine and cosine? So this one is cosine over sine, and secant is 1 over cosine. Cosines cancel, so we get 1 over sine, which is cosecant. And that would match up with A. Okay? It's okay. All right, let's see, we've got secant squared x minus 1 over sine squared x. Anytime you see the squareds, you should automatically be thinking, I bet there's a Pythagorean identity I can use. So the Pythagorean identity here is on the top, we have secant squared x minus 1. Well, remember we have 1 plus tangent squared x. I feel like we've used this a couple times already.
Oh, you can't do
Equals secant squared. If I move 1 over, now I have that tangent squared equals secant squared minus 1.
that.
So, because I saw the secant squared and I saw minus 1. So it was a little bit complicated. Usually where it's more complicated is where you want to try and do something with it. So I'm going to take and plug in tangent squared for that.
Okay.
So now we have tangent squared x over sine squared x, which is not something that we have in our book as a choice. So then let's go ahead. I want to make tangent squared into sine and cosine. But the problem with that right now is that turns this into a fraction, and then I already have a fraction. I don't really like that. So what I'm going to do is I'm going to rewrite it right now. Tangent squared times 1 over sine squared. So do you guys understand what I just did?
Yeah.
Okay, I took this and I just moved it over so that it's a multiplication problem, because now I can look at tangent and replace that with sine squared over cosine squared. And then
1 over cosine.
my sine squareds cancel, right? So now I have 1 over cosine squared, and then I can,
Perfect.
then I can rewrite that as secant squared, which is e. Now, when you guys are doing 15 through 20, I'm pretty sure at this point, when you do your last one, you'll be like, I already know the answer because it's the one that hasn't been done. But you do need to show your work. You need to know how to do it. So we're going to go through. We have now cosine squared of pi over 2 minus x over cosine of x. So in your identities, you have an identity for this business, although I think I put a 90 here instead of a pi over 2. It's one of those that we wrote down in class.
Oh, hold on.
Right? So this is called a cofunction identity. So the idea is in a triangle, cosine of the other angle would match up with sine of the original angle. So this top one is going to turn into sine squared of x, and then it'll be over cosine x.
Be sine squared. Why is it sine squared?
Well, it's sine squared because cosine was squared.
Why is it of x? Because that's just a symbol for you.
Did you see your identity? The identity says, it says cosine of 90 minus x equals theta.
Oh, mine says theta.
I'll put theta in there.
That's why I was confused.
Yep, of theta equals sine of theta. So it doesn't really matter what you use right here. If it's an x, a theta, a u, it doesn't matter. It's all the same thing. And then this pi over 2 is the same thing as the 90, just in degrees or radians. So cosine of all that would equal sine, but we have squared, so we just made sure ours was squared. All right, so then we need to simplify what we have still. We have sine squared over cosine, which probably isn't the best thing to have. I'm going to look at what do we have for, the one that we have left is d, and d says sine times tangent, right? So here's what I'm going to do. I'm going to take this, and I'm going to write sine of x times sine of x instead of sine squared over cosine x. Yeah, you can break it up. That's what squared means. Take it times itself, right? Now, sine over cosine is tangent, so this is really sine times tangent, which was d.